Hello, everyone, and welcome to Handmade Hero, the show where we code a complete game live on stream. Coming back after the holiday break. We did not have episodes last weekend, but we have them this weekend. We are kind of getting close to lighting I'm happy with, actually. We've done a pretty good job of sort of navigating through the rather difficult waters of real-time lighting. And I think that we've kind of gotten to a point where I can see this being the thing that we would ship, right? So the key components of it are smoothing over time and specifying what light gathers go with which rendered objects seems to be the crucial aspects of the lighting model that make it work for us. And so what we're really trying to do now is start to solidify things down into a shippable system that's like reliable and not too slow and so on, right? And so we only just hit upon all of these things kind of coming together last time we programmed, so 2 weeks ago. And so we've got some bugs in there that already we just have to fix. The assignment, we had just added the ability to assign specific lighting samples to elements in the world, and I believe that stable assignment is broken at the moment. So we gotta actually solve that problem. It's just going to be some bugs in there that we've got to fix, and then we have to start moving our locking down how that stuff gets transmitted to the renderer and actually put in the ability to do sort of a multi-resolution approach on the GPU as well. So we basically just have like a bunch of finishing work to do now, but I'm pretty happy with sort of what we have discovered in terms of a reasonable way to do some lighting in real time that gets the sort of flow of lighting out into the world that I wanted for the game. I think it'll be sufficient, and I'm happy enough with it so far that I think it could be what we go with. The game does not require super advanced lighting for any particular gameplay things. It just wants to be able to have a nice coherent lighting environment, and so I think that this will accomplish that. Certainly if the game was really about specific reflections or seeing people in mirrors and things like this, we haven't taken it to those kinds of extremes at all. So if you were trying to do a game that had really specific lighting concerns, this is maybe not the lighting solution that goes as far as you would want. But again, this is not what we need it for in this game. What we need it for is atmospherics, sort of effects that are going to make you feel like you're really in the world, things that sort of give you information about where things are, like, fires that are lit and kind of glowing and things like this. Maybe things like carrying a lantern around might be nice, etc. And that's the sort of thing that we can do with the system that we have now. So I'm going to say that that's what I'm happy sort of turning the crank on and shipping. So let's just revisit where we were, because I just said we had some bugs, but for those of you who... Oops, typed the wrong thing there. For those of you who may have been, working on other stuff for the past few weeks and don't remember where we were in Handmade Hero, which for some reason doesn't include me, even though I was working, I happen to remember. I guess because, hey, I'm the one who has to program it. It's my responsibility to remember. I will refresh your memory as to what I mean by there were some bugs in the thing that we added that we needed to fix at the end of the last episode. Specifically, what we were doing is we were adding some smoothing, and in order to smooth the light samples over time, there were two ways that we could have approached this. And each of the two ways of approaching this were... Well, you know what? That's interesting, because I thought we had... Did we just turn on... So I guess I need to refresh my memory, too, because I actually don't remember us having a black screen here. I remember us having a smoother, I remember us having some lighting running here, and the lighting was only working on half the grid. So I don't actually remember this being a problem. So maybe I am not remembering either. But point being, whether I'm remembering that part correctly or not, it was already buggy, and we needed to sort of fix it. So the first thing that we need to do today is get those lighting assignment points working correctly. And I believe we left a big to-do as well in the render group stuff that sort of talked about the problem. Where was that guy? It was here. So you can see, very important, finish implementing and debugging lighting index assignment in the render group before doing anything else with lighting. And you can see this is the thing that I left at the end, which we definitely need to do, right? So anyway, I'm going to go ahead and proceed under the assumption that the bugs that we had in this system that were causing it to only partially work are probably the same things that are causing us on fresh reboot to not work, because we're probably just not initializing things properly or not sending down the right stuff. And so it was just accidental that it was half working before, and we really have to go ahead and make it work properly, right? So let me just go over what we were doing. We have these things called entity pieces. That's just a way of allowing a particular entity in the game to have a couple different like sprite components, for example, with it. And what you can see about these entity pieces is that they have a way of assigning lights now to themselves. And lights is the wrong word, sorry. A lighting like sample point to themselves. So the way that it works is inside the lighting system, we have things that emit light, and then we also have things that occlude light, and things that pick up light as sort of sensors in the world. And so occluders are things that can block light from being transmitted around. So those are things like our cubes or whatever that are going to create obstacles that the light cannot flow through. And then we've got emitters that are sort of the same thing as obstacles, only instead of preventing light from going through them, they are sending light out. And then finally, we've got light, actual lighting points, and these are points that are trying to collect what light they will see from where they are, right? And so what happens is, for each entity visible piece, we have a lighting index, and that lighting index tells us the first light in a range of lights the first lighting sample in a range of lighting samples that will be used to light this piece. And the reason that that's stored in the entity structure is that's because it has to be coherent from frame to frame, meaning that on frame 0, if we say that this particular piece of the entity is getting lit by these n samples, then on frame 1, we have to say the same n samples. Now, the reason for that is because we don't want to deal with trying to interpolate the lighting based on the location of things. Because in order to interpolate the lighting based on the location of things, we would run into a situation where things have to do spatial lookups. And one of the things that I'm trying to avoid is those spatial lookups, because having to deal with the voxel was kind of annoying. It just added a lot of complexity, and we had problems about the fact that, voxel cells, we'd have to make sure that they were always filled, and if there wasn't any particular thing in that voxel cell, then what would we fill it with, and how do we interpolate between them? It kind of starts to exponentially grow, a cubed number of samples that we have to take, and blah, blah, blah. So I really just thought it was a better way to actually do frame-to-frame direct assignment rather than things being based on spatial matching. And so that's kind of the way that we were going with it. Now, when this actually happens, this light index here that the entity visible piece is responsible for sending down, what you can kind of see is that light index, when you do a push light or a push cube, which are the two things that are currently getting sent down to the lighting system, I don't think push bitmap does it. Yeah, it doesn't. Those are basically specifying these lighting indexes, which are saying where these things should go, right? Where into the lighting array these things should go. That actually reminds me what happens in push bitmap. That presumably sends down a light index to 0, which means that bitmaps aren't lit, which I think is the correct thing that we're observing here. Right? You can see that bitmaps are not lit right now. And that's by design at the moment. They will be lit later. We'll actually scatter points on them or something similar to that. But so you can see that only lights and cubes are supposed to be participating in it. So what we expect to see, right, is we expect to see our light here that's floating right here. We want that to be scattering light out to our cubes, and we're not seeing that right now. So that's the immediate bug that we are seeing. The bug that we saw before that, when we were working on this last week, was that we were only getting like half of our world was getting lit and the other half wasn't properly, and so on. So our goal is to debug this thing right here. And if we look inside the render group to see where that was actually taking effect, what you can see is that let me go ahead and search for that push cube. There it is. We've got sort of this lighting index store thing. That's what was getting passed here. What happens is when we come down through here, the light index store, if it is valid, meaning we actually got a pointer, which again we wouldn't under say push bitmap, because when we're doing things like push bitmap we don't get any. But so when we do something like a push cube, and if we see a light index store, what we do is we say how many lights we're going to be putting on this particular thing. Then we, and in this case, light count is per face of the cube. We then say, okay, if the thing that's already there in the address that we're going to be storing the light information, storing the light index back to, if there's something that's already in there, meaning if it was non-zero, then we're going to assume that it's one that got assigned on a previous frame and we're going to use it. Otherwise, what we're going to do is just assign it one. And again, you can see here that this is already a to-do. This won't work when things are moving in and out of the active set. So what we actually need is some kind of a thing that takes chunks and reassigns them. It's just got to be like a free list sort of a thing. That's not going to be hard to implement. But I don't think that's our bug right now, because right now we're just looking at something that's not really getting reassigned, I don't think. Now, maybe it is, and maybe that's why this is happening. So it could be that I'm actually pretty stupid for saying that. So maybe we should go ahead and fix that first. I don't know. But point being, I want to investigate the bug first before jumping to any conclusions about what is and isn't the problem. But point being, that has to get fixed eventually as well. So then what we see is that, hey, whenever this happens, we also sort of advance the light index by the light count times 6, which is 6 faces of the cube. That's just so that when we go through, we're putting things in places that are ostensibly new. When we go ahead and do our push quad, you can see that we send down the light index. So whatever the light index was, we send it down here, and we increment it as we go. Now, one of the things that's a little bit busted about that is that means that anything that was not getting lit is going to be kind of wrong, because it will actually still assign lights to it. It should assign 0 this whole time, but it wouldn't. Oh no, that's not true. Light count would be still set to 0, so that's fine. So it would pass a 0 in all these, so that's fine. I take it back. There's not a bug there. So anyway, when we go up to push quad, what you can see here is that the light index just flows through to the actual push quad, which you can see here has like the emission value, the light count, the light index. Let me just make sure those are getting passed in the correct order down here. Light count, light index, yep. So when we go through and go to push quad, what you can see is that the light index and light count are stored in each vertex. Again, that's wasteful. It's a to-do inside our vertex structure. We just did that because in getting it working, I didn't want to bother adding a new vertex stream to pass down that information, but we can actually optimize that out and pass just one light index and count for each primitive. So this can be simplified, but at the moment we're just passing on every vertex, so it will always be there no matter which vertex you're looking at. So that's probably fine. So that's how this works. And that information just goes into the stream to be used later on. Now, that gets picked up eventually by the lighting code. So if we take a look inside where the light actually happens, you can see that in extract reflectors from quads, we kind of come through here and we build, this code will go away eventually. This will just be welded into the thing that's actually outputting the entities in the first place. But what we're doing is we're going through and we're putting points on the surface of these quads proportional to the number that we were asked to do. Now, we didn't actually write this code because, like I said, it's not real. It's just here for its placeholder. So it's actually just locked to the always use the same pattern because we know we're always sending down 4. But in the future, we'll be scattering these lights more intelligently, scattering the sample points more intelligently, presumably. Anyway, so what we then do is we come through here, we output all of our lighting information into these little solution elements. We then run our compute light propagation function, and it goes through and it propagates the lights all around to these light samples. And when it's done with that, it goes ahead and says, all right, I'm going to go through and I'm going to normalize all of my results, right? And I'm going to linearly interpolate my results that I got, meaning the results I got this time. I'm going to linearly interpolate from what I started with, which is the last emission here, right? I'm going to interpolate from what I started with toward my solution every time so that it slowly, it will slowly sort of interpolate there. Now, what we do to avoid startup problems is if we have never gotten a valid lighting solution, so meaning on frame 0 where there wasn't anything beforehand, we don't want to lerp because we're lerping from bogus values. So we want to just set the value equal to whatever it would be on this frame. And the way that we do that is we just look to see whether this solution was ever marked as valid. If it's never been marked as valid, then we just assume that we can linearly interpolate between the value and itself, and so it will always get itself no matter what the value of t is, right? So that's how we're working at the moment. Now what we have to do is investigate this and find out where we're going wrong. And why everything is coming out black. So the first thing we can do here is let's go ahead and switch back to a debug build. Let me go ahead and switch to the OD here. And if I go ahead and run the program now, it should still be, yeah, it does seem like maybe we're just not getting any emission, honestly, because you can notice how fast it's running too. That's how fast I think it would be running if you just weren't emitting anything, right? Which is kind of bizarre. Yeah, it's kind of weird. And lighting disabled should always be false anyway. Anyway, sorry, I lost my train of thought there as I was looking at our little menu thing here. So anyway, point being, since all these things are coming out black, what we need to do is kind of go up the chain and just take a look at where we, what sorts of things we're seeing in terms of stepping into the debug code, why we're never getting any emitters emitting anything here, because it looks to me like we're never getting any emission at all. The reason that I say that is because currently our algorithm will slow down proportional to how much emission there is. And the fact that this is running in debug mode right now, meaning the code is not even running through the optimizer, and it's running at close to 60 frames a second, that just suggests to me that we're not really getting any lighting happening at all, like nothing is actually starting the emission process. So one of the things that I can do here is maybe I kind of come through here and first of all, let's just make sure we're actually pushing a light on to the stack at all. But here it looks like we are. Let's see what the emission value is. So here's the light that has an emission value on it. And let's make sure that that gets assigned some proper light indexes here. You know what, I should just use a step into. Or I won't. So here in the pushCube function, just looking through, it does correctly assign a light index here. Yep. So it's doing what I think it should be doing, right? There's nothing weird going on here that I can see so far. And what I can do is I can take a look now in the lighting code just to see whether or not, I don't know why I just typed render group, that's good. I wanted to switch to render group and I forgot that the command that when I'm in Visual Studio is not that. Where is the render group? Can I grab it here? There we go. So what I want to do here is I just want to set a breakpoint in the lighting so I can actually see what's going on in terms of whether we get any emitters and why they're not getting pushed out into the world at all. Because it looks like the lighting isn't even running on them. That's what it looks like because we're not getting a frame rate hit from it. So here it looks like we're not running extract reflectors from quads, right? So we must have the lighting turned off in some way. Maybe I just forgot how we were running the lighting or something like this at the end of last episode. Maybe I just turned it off really quickly. You can see we're not even calling lighting test. So if I jump back to Handmade worlds, that would probably answer the question as to what it is I forgot. So recompute lighting is false if the F key is pressed. 5, 6, 1, 4. update lighting is 0. So it looks like if I just press F4, okay, so there we go. I was not on crack. I just forgot that we had bound it to a key. So that's good. This is the problem with binding things to keys. Sometimes you forget what those keys actually are. So instead of F1, we had bound that to F4. Maybe I should go ahead and take that out and put that on by default. So there's us sort of running the thing that I was saying before, but that still has bugs. You can see that the lighting interpolation is actually working quite nicely. Down on the bottom there, it's kind of flicker free and tracks me relatively well. It's not great, right? But remember, this is running all in software, so if we ran it in GPU, we'd get even better results, and it could update much more quickly. So, I think this is totally plausible, and I'm not too worried about it, right? I'm not too worried about where that's going. What I am worried about is the thing that I was saying before, which is that you'll notice that for whatever reason, when I'm moving the main light around, you can kind of see that everything sort of seems like it's working properly. Like, it's like, yeah, this seems like pretty sane lighting. If we assume that these guys are lighting that up or whatever, right? But, before our snake got stuck in the corner, backed himself into the corner, what hopefully you can see here is that, with the faster moving guy, yeah, it trails behind him a little too much, but look at what happens right here. When the snake moves into the upper corner, its light stops working. It just stopped, right? And we have no explanation for that. So I'm assuming that the problem that we're seeing there has to do with how we are assigning these light outputs, like something to do with what happens when the draw order changes. For those lights, you get some kind of really erroneous result. Again, we haven't implemented the whole lighting assignment scheme, so it could even just be the thing I was talking about before, where that thing doesn't have a proper allocator in there. I'm not 100% certain. So the important thing to remember there is just that, yeah, that could easily be that, or it could be something else, but that was the bug that we wanted to track down. Now, since the updating lighting stuff already bit me once there, not turning it on, I'm going to just turn it on at startup by default because it already runs fast enough even without being optimized on the GPU at the moment for us to go ahead and keep it running all the time. So we don't really have to worry about turning that off at the moment. So what I'm going to do there is take this updating lighting boolean here, and when we create the game world, for the first time, I'm just going to set that equal to true for now. So that way we will have one of these that's on by default. So you can see here where we do our set game mode and we push a struct for world mode on here. I'm just going to go ahead and say that updating lighting is equal to true here. And then we can always delete that line if we go back to doing something slow with the lighting that we're worried about running, right? But now when we boot up, we've at least got the lighting running. And so now we just have to figure out why when our little saucy snake gentleman here hops up onto this, whatever you want to call this, the top half of the arena, why the lights no longer take effect the way that they are when it's on the lower part. And again, the fact that it's leaving a long trail is not concerning. That's just the slow blend over 100 frames. We can trivially make that not happen by switching the blend coefficient here to something higher. So if we only blended over 10 frames, for example, we would get much more flickering lighting. You can kind of see that the lighting is sort of a little flickery now, but now you can see that the light cleans up much more quickly as the snake moves along. So that's like, quite a bit more reasonable, right? And it has much more quick response to, as I'm moving this light around as well. So that seems pretty good, and I'm, again, relatively happy with that. But again, the problem here is just that we don't know why when it comes up on here it's not working properly. So there's two things that could be happening there. One is that something's happening with the assignment of the receivers in the top half, and the other is that something's happening with assignments of the transmitters in the upper half, and we don't actually know which one of those is happening. So what I'd like to do is try to figure out which one is happening. I'm going to start by assuming that it's assignment of the emitter, right? That it's these that are getting assigned erroneously. And the reason that I want to start with that assumption is because it seems like my main cube light here that I move around is not having the problem. So if it was a circumstance where it was the receivers that were getting assigned improperly, then I would have expected it to be the case that the lighting would not work in the upper half for my cube light either. However, since I'm seeing it work for my cube light, I'm assuming that it's got to be something specific to these emitters that's causing the problem. Ergo, my assumption is that when this, remember, these, when we simulate the world, we simulate a subset of the world that's the world we can see at the current time. And the way that that works is we take entities that are packed into world storage, we unpack them into a simulation region, do our simulation, and then pack them back. What that means is that the order in which they are rendered is based on where they are spatially in the world, because we pull out all of the world storage chunks that we can see in a region, do our computations, and then put them back. So it's entirely plausible that for this person to hop up into this region of the screen, or I should say this region of the world, that would change their assignment in such a way that they got different draw order and hence some kind of different thing happening with their lighting indices. I'm not sure what. Now, since lighting indices are stored with the entity, I'm not 100% sure why we would ever see this bug, because in theory, all of the entities have been seen at this point. They should all have light indices assigned to them, and so they should be always outputting the same light indices no matter where they hop in the world. However, again, we're dealing with something that's buggy, so obviously my assumptions about what's happening, there's something wrong somewhere. So I'm choosing to assume that the something wrong happens to be in there, somewhere in that set of assumptions. It might be somewhere else. Let's find out. So the first thing I'm going to do is I want to go ahead and take the lighting index of that piece there. I want to see what those lighting indices are. And I think the easiest way to do that is just to take a look at that push light call again, because the only entities that are actually having their lights pushed on there is one of these, are these people right here. Now, why that did not stop, because we're not in debug mode. Sorry. That function probably got optimized out because it's just a little tiny function call. So here's that push light call, and what you can see from the push light call is that if we go up the stack, the place where that's getting called is specifically when there's one of those lights that's happening here. And you know what I can do too? Let's actually take one more step before we debug, just to make things a little bit easier on ourselves. Let's go ahead and take out as many parts of the equation as we can, so that we're going to be able to most easily zero in on the particular cause of the problem. So what I'm going to do is I'm going to comment out this push light call so that I no longer control light, right? So for starters, I got rid of that. We now only have the little snake gentleman hopping around, as you can see. And the other thing that I'm going to do is I'm going to go take out the push light calls that are happening on behalf of the other parts of the snake. So actually, when you add the snake in, instead of it always getting an add piece light like it does here, what I'm going to do is say if the segment index is 0, then sure, otherwise no. And I don't know if I have to make that 1 or not. I'm not sure if the snake segment happens if it's snake segment 0 or not. Let's find out. So there we go. Now you can kind of see that the segment index, it's only the head that is currently a light source now, and you can see that the bug persists. So we have only one light now, and that should give me what I need to make this work. So if we go into the running code here, and now I set that push light breakpoint, right? We can see that we're in a state where we do have the light working properly. So I can come in here and I can look and see, oops, let me use the step into I tried this before. It's gonna work this time, right? Right? There it is. Oh, it's just showing, that's interesting. Instead of showing up over here, it's showing up over here. Don't know why, because there's the arrow, so it should show up over here, but you know, Visual Studio has its own special way of enriching our lives every day. And that's just one of them. So let's go into the pushcube call and let's take a look at what we're actually storing in terms of the light indices. Here we go. You can see that we do have one here. We should have one in here already. We do. We pull it out, and so we're storing to light index 1033. Fantastic number if ever there was one. There it is right there, in fact. So we're storing to 1033, and then that means we're going to store to 1033, 1037, 1041, 1045, 1049, right? 1053. So those are now all stored in there. That's all great. And so what I want to do now is verify that we keep using that same light index every time we come through here. That's what I would like to do. So there's that 1033. I can set the breakpoint out here and inspect that value totally easily, right? 1033, 1033, 1033, 1033, right? Always good. So let's go ahead and disable this breakpoint, and let's go ahead and wait till the dude is up in a place where he's not lighting anything, right? Which is right now. So now I've set it, and you can see he's hopped up in here where he's not actually emitting light to these surfaces. So what I want to see now is anything weird happening. So you can see 1033, that's still the same light that's been assigned here, right? And when I come through, yeah, presumably all of this stuff is functioning as normal, I assume. Light count is 4, light is 1033. And we're assigning these to the exact same lights, 1037, 1041, 1045, 1049, 1053. So I'm not really sure why we're not lighting those, but let's just push through and see what the lighting code actually does. I mean, another possibility is somehow the light propagation is not propagating to lights that are far away in integers. I don't know. That's a mystery one. I honestly have no idea why that's happening. So this ought to be entertaining. So if we come down here to extract reflectors from quads, and you know what the other interesting thing is too, you can kind of see here, it looks like this could just be the blend happening, but what you can kind of see there too is I think the light is still able to light this stuff. So this light is emitting light into the world. It's just not emitting light into the upper half of the world. So it must have something to do with why an emitter at 1033 cannot spread light to emitters in certain index ranges or something. But I'm not sure I know how that's really possible. So we're going to have to dig a little deeper to really even get a clue as to what this bug is. I honestly can't think of what it could be. I'm a bit stumpy. I'm stumpy right now. So taking a look at what we're extracting here. So the stuff we're extracting is exactly what we would think for, you know, light. We have a light index and a count of 4, right? And we're putting these guys out in there. We're filling in the emit and direction information here. I'm assuming we've got a lighting solution, right? So it should be the solution. Again, Visual Studio enriching our lives. Should have last is valid set to 1. It does. Again, the point count is 177, so 1033 kind of falls sort of in the middle there. We don't have a lot of ideas about what precisely... well, you know what? Now that I think about it, Another thing we probably should do soon is color the world based on light index, because we did do something like that before. We know there's 177 different lighting points in the world. And so one thing that we should do is go ahead and see if we can't color the world from 1 to 1777 in terms of shades. And that way we can kind of see where the indices are assigned and see if there is some coherent thing that's happening to the light indices in that top area, because that might give us, again, a clue as to why they're having a problem. So in here we sort of look through and we try to figure out what our point count's going to be. Presumably, as we come through these light indices here, we will have some idea of what the maximum value is. Once we're done running it, we find we have 444 surfaces. I don't know how many vertices we have processed because I can't verify that number here. But what I could do is say here is the base pointer. Here's the current pointer. So if we've retired 1964 vertices, right? So the quad count should be roughly a quarter of that. So 1964 divided by 4 is exactly what we would expect. So if each quad had 4 light samples, 16 light samples on, if each quad had 4 light samples on it, we would have expected 1964 points, but we're not seeing that. Now, that's possibly okay because, again, in fact, it's definitely okay because a bunch of our quads are sprites, and those sprites don't have lighting. So that's totally okay that those would be skipped there. I'm just trying to think if somehow those getting skipped might somehow misassign. I'm just trying to figure out if somehow those getting skipped can misassign the indices so that maybe they're looking at parts of the lighting array that are not getting filled. And I don't really know how exactly that would happen because you can see here we grab our light index off of vert0's light index. That's the same thing that the code in the shader should be grabbing from. And so I'm not sure why we would be getting something weird happening there. Now I gotta go look to make sure that's true. Maybe the vertex shader is actually assigning things incorrectly there, in which case that would be fairly important part of why things were working wrong, but I'm assuming that that's working correctly. So when we come through here, we're looking at solution points that are based off that light index. That light index is pulled directly out of the vertex record, and the surface light index itself is also driven off of that. So that, again, should correctly say that this particular surface corresponds with this particular range of light indices, which are matched to the vertex. So it's what that quad will pull from when it is done. Now, after we do compute light propagation, which I'll check later, when we do that compute light propagation and we output the points, you can see that we go through the points here and we pull out these values. Oh wait, this is our debug output lighting points. No. We want output lighting textures. So output lighting textures, we go through here and we use the point indices and we pack the arrays that we're sending down based on just the point indices. So what that means is the point indices have to line up with the light indices. So let's see if that's true, right? So is solution points point index, is that going to line up properly, right, with the light indices? What that means is that the light index, as we come through this loop up here, should be used to access the point array. And what you can see here is it does appear to be the case. So there's lighting point, right? You can see it doing its thing here. And similarly, emit 0 and average directional light, also driven off the light index. So it does look like everything is driven off the light index there properly, as it should be. So the other question is, well, when we're outputting them, are we actually correctly outputting all of them? So what you can see here is when we do point index loops, we're going to solution point count, which again is 1777, which is, I think, probably the correct number to be doing here, since again we're skipping sprites which have bitmaps on them at the moment. Just the bitmap sprites, we're only doing the cubes. So yeah. Excuse me. Again, not having the stroke of inspiration here in terms of telling me. Maybe it's because I'm too yawny. Maybe I'm too tired. So I'm going to go ahead and say that I think my next step is just to gain some insight into how those lighting indices are assigned, so I can see if something weird is going on. So let's just take a brief moment, because I do want to keep pushing the debugging more, but I feel like I'm a little bit too aimless in my debugging right now. I don't know where to focus my efforts. And so what I'm going to try and do is find a clue to how to focus those efforts by changing the way the OpenGL shader is shading, so that it shows me what the light indices actually are. That's what I would like to do. So here's the Z-bias program. You can see in here the way that we're doing the lighting. We grab the light index out here, and we loop through the light count like this, fetching the light values and doing the ops on those light values right here, right? So if I wanted to do things differently than this, what I could do instead is, rather than texel fetching this information off of light I, the way that we're doing it here, I can come down here and say, well, instead of that value, let's instead make L be equal to something based off of the frag light index. And the way that we would do that is say, okay, let's perhaps say that the red value is going to be maybe the low part of the frag. Well, you know what? I could start by just doing grayscale. Since I know that this is how many I've got, what I could do is say maybe maybe something like this. Oops. So I know that now my grayscale value that I get here will actually just tell me what it is that I want to know. And similarly, I can do something more like this. In fact, I can leave these even on, right? And what I do is I just clobber the value that I was going to use before with an actual direct lighting value that just tells me exactly what lighting index is assigned, right? So what you can see out of this is, lo and behold, my suspicion is at least somewhat correct, that the values of the lights that are being assigned here are definitely coherent with the spatial location in the world, right? So low lighting indices are down on the bottom, high light indices are up at the top, and so what we're basically seeing is that the higher the light index gets, the closer we get to failing to compute the light correctly. So it looks like about the halfway point, give or take, somewhere around there, we stop producing lighting for the snake. Now, remember, we still produce lighting for the moving cube. And that's the really weird part about it, right? It's not like the lighting doesn't work at all. It's just that the moving cube light doesn't work in this particular case there. So that's particularly strange. I'm going to watch one other thing here. So what you can see is there's the light index of this guy, and it never changes. I'm just trying to verify there that it's always the same, and it is. or at least it appears to be. That was what I was trying to verify before numerically. We always saw it being 1033. So that's good, like we kind of get the idea there. So I'm going to do one other check here. What I'm going to do is I want to see a breaking point so I can get a little bit of a better idea of what's going on there. Rather than assigning it based on grayscale, I'm going to say, okay, surface select RGB is going to equal something like green, unless, of course, the frag light index is greater than 1033, which is our lights value, and then I'm going to change it to red. So red values will be ones that are above 1033. Green values are ones that are below 1033. So the reason I did this, and you'll see a very suspicious pattern emerging here, all of the places where we are not getting light contribution from our 1033 light source happen to all be above 1033. Now, why did I think to do this? Well, A, because it's just a convenient number that is sort of in the middle-ish of the range, so I kind of got a little bit of a sinking suspicion about that. And the second reason I did it was because the difference in my mind that when I was thinking about what the difference is between the light that worked and the light that doesn't work is the light that doesn't work happened to got pushed on last. Remember, it's a push light. That cube that I was moving around is a light is a light cube that gets pushed on by the world code at the end of the render, which means it would have had a very high, if not the highest, light index value, and that one was working. So in my mind, I'm thinking maybe I have a bug where light only gets distributed to things that are lower than the value of the light source and not higher than it. Lo and behold, that looks like exactly what's happening. So that tells me that my light propagation loop probably has a bug in it somewhere where I'm not looping over lights. I'm not able to transmit to lights that are, say, higher than the emitter index. So you can see right here the way this loop works. For example, let's just start with this one and see. I'm not sure it's in this loop. I'm just starting here randomly. But you can see here I've got my emitter index, and I'm looping between the from 1 to the point count. And then I'm going through here, and I'm doing my emission from these points, right, as we go. So when I'm going through here, the emitter index to start with would have been 1033. That's what we're looking at in terms of where we're starting. And presumably we come down to this code, and presumably this actually does execute. Why do I think it executes? Well, I think it executes because this light is propagating to other surfaces, just not ones that are higher than 1033. So when I look down in here, I see, okay, then I'm going to start doing ray casting. I'm going to sample the hemisphere here. I'm going to do my ray casts. And then I'm going to look to see whether the hit index that comes back is less than the surface count that I've got for the solution. Now, the surface count, let's make sure that raycast actually returns surfaces and not points, but it must because, again, it's only looping over surfaces. So that is what it sends back here. That's what we would expect. So result index equals source index. That source index is going to be within the surfaces. So if it hits something, that's what it's going to get. That seems fine. When I come through here, I then say, all right, let's pull out that hit surface using the hit index. Here it is. Then we'll say, okay, let's go from 0 to however many the hit surface had. And we'll go say the point index we're going to distribute to is going to be equal to the hit surface lightness plus the surface point index, right? That's what we would expect because in here we're storing an index into the array where this guy starts. We're coming through the hit points on this guy by saying, okay, for each of those point indexes, let's loop over them, right? And look at the distance between them. So the distance between where we hit and where the point on the surface that we're looking at and where we hit, we're going to find whichever the closest one was. So if the closest distance squared here is greater than distance squared, we're going to use it, right? And then what we're going to do is we're going to accumulate the sample if we found one of these closest point indices, right? I don't see anything immediately in there that is biasing us towards not counting stuff higher than our emitter. So I don't immediately see what's going on, but what I can do is I can step into this code and watch what it does on number 1033. And then I guess I will see why we are not distributing to any surfaces above there. And one of the things that I would mention sort of in passing is when one of the biggest source of problems in graphics programming, programming in general, but graphics programming specifically, is that you tend to have a lot of these sort of disparate arrays that all pull together to create some solution to something, right? Whether it's vertices on a mesh or lighting sample points or anything else, you tend to have a lot of indices and they all have to line up at the end. And it's really easy to get into a situation where something isn't lining up, right? Or something's doing something wrong with these indices. And so we're probably looking at a situation like that, and they do take a while to debug. The reason they take a while to debug is because debuggers are garbage, so they don't allow you to do things like trace back points easily through all the things that affected them and go, oh, okay, I see how this data flowed through here and why we got the wrong result here. So you end up having to do a lot of stage debugging like I'm doing now. In the future, in fact, I made a tool for debugging this stuff at RAD one time called Mustache that used to make debugging problems like this basically like shooting fish in a barrel. Unfortunately, and it was for doing video debugging. Unfortunately, we don't have those tools in the general case yet because people don't innovate on debugging anymore, but someday when they start to again, trust me, these tools are not hard to build. People just don't build them. Anyway, moving on. So in here, we've got that situation occurring. Something's wrong with our indices there. So let's go ahead and step into it. Now, it's going to be hard to step into this at the right time. So rather than try to do that, what I'm going to do instead is add some code that will allow me to trigger specifically when I think the bug is happening, starting from most specific case and working our way backwards to more general cases as I see them. So the most specific case would be if at some point we actually were about to do the operation I'm saying I don't think happens. So if the emission index is equal to 1033, right? So I'm emitting from 1033, that emitter. And what I can really do is say, well, if it's greater than 1033, and it's less than or equal to, what are we saying? That there's basically on that cube of emission, if it's 1033, then we've got 6 sides of the cube, each which have 4, so there's 24 on there. So we're actually going to go up to 1057, which I think we inspected before as well. So let's say we're looking at the emission being in that range, right? So if the emission is in that range, then we know we are trying to transmit from the thing that we're saying isn't transmitting properly. Then let's see if the point index that we're testing at this point happens to, pun intended, happens to be above the 1057 range, right? So if it's a point that we think we shouldn't be seeing any transmission from, because we know there's a bug there that's not getting transmitted. If it's a point that we think is buggy and we are trying to emit from the emitter, which really probably, yeah, it doesn't matter. Let's go find out why this isn't triggering. So either we hit here and we trace out to see what's going on, or we don't even hit here, which means we move this up one stage of the loop, right? So let me go ahead and set this to OD here. And let me come through and run it. And so as this is running along, I'm going to go switch to find that location and just go ahead and take a breakpoint there. So what we can see here is, unless I've really mistaken the situation, I have now correctly captured a point where we're trying to do an emission from one of the points on the snake emitter, right? And we're trying to emit to something that is not gathering any emission from the snake, right? So we've hit a point where we would say that that's what we wanted to do, right? Closest point index is above 1033. Closest distance squared is just 1.05, right? So off we go, looking at this here, finding that closest point. It looks like we found a new closest point, again, still above range. That one was closer, so that's probably the hit. And now we have finished, right? So we found a point we want to distribute some emission to. We go through the closest point index. We're going to call into accumulate sample with this closest point index. So we go in there. Let me do that step into again. I'm coming out the back now. I know to look, right? So accumulate sample comes in. We compute the angular fall off, which is not going to nullify it. We compute the power, again, not going to nullify it. The weight, not going to nullify it. We generate our result, which is a reasonable value. We have our destimate C. Value here, which we can sort of check to see what's going on in terms of where that is in our loop. It's a little bit hard to do at the moment, but what we can do is just snap this pointer value here. There we go. Just so we can remember which one it is. And we can even go through here, and this is a V3 pointer, right? So we can take a look at what it's actually set to. So what we can do is watch that accumulation happen. So there we've accumulated some lighting in there, and we've returned our result out. That's going to subtract away the lighting, right? Then we're just going to keep doing it. So what we should see there is, yeah, all of that light just gets, it is getting distributed in there properly. Let's see what happens at the end of the loop. So if I jump out to the end of the loop, so what you can see here is by the time we get to the end of the loop, all of its light has been dissipated. So something is happening where all of the light that should have and we saw getting accumulated, right, is getting wiped out. And the only real way it can get wiped out there is in this line here, where the retained light, where it essentially gets, okay. So there's our answer. That's just dumb. So what you can see here is us being fairly stupid. This needs to be a plus equals, not an equals. We're taking an amount of source light, and we're saying any amount of source light that did not get transmitted needs to get added back in. However, instead of adding it back into the light that's already been accumulated for this point, we're just cold wrapping it right over the top, right? That is almost certainly the entirety of the bug. So it wasn't really even index. I mean, it happens to be index-based because of that meant that you could only transmit light sort of earlier to people who were earlier than you, who hadn't wrapped already. Pretty simple fix, as it turns out. So let's take a look at how that goes now. I guess I'm also going to have to change the shader in here to no longer be outputting in debug mode. So let's go ahead and get rid of this stuff here. There we go. Okay. So now our lighting transmission should work when it gets up there. And lo and behold, it does. All right. So now I can go in here and in theory, return things to semi-normal. And we should see everything kind of playing nicely together. I can go back into the world mode and add our lights back in. I can go into the debug light and turn that back on. And now in theory, all of these should be working correctly, right? So that looks pretty clean. And now I'm not seeing any more of those artifacts. Our light transmission should also be better and more stable now, because now we're not having this forward-only transmission. So each iteration of our lighting is doing better work now than it was before. And so we're also probably getting a better light solution even for the things that were already working, because that was just reducing the effectiveness of our light propagation. So that's looking pretty nice. I'm pretty happy with that. I will say there's still a little weirdness, I think, maybe. I'm not 100% sure. It's a little hard to say. But I'm not 100% positive. Oh, no, I think that's right. Never mind. I was going to say I'm not positive these should be lit, but they definitely are. In fact, it's doing the lighting just right. It can't light that surface, but it can light this one, and it is. So that seems pretty good. I'm relatively happy with that. And the other thing that I would point out here that at least that I'm hoping will happen, and I don't really know if it will or not, but it's the way that I'm sort of approaching this, is, for example, you know, the difference in lighting on these squares is desirable because one of the things that I wanted to have happen in the game is, you know, I want to have it emphasize the fact that the game is square-based because you hop from square to square. But other times we may not want to emphasize that. So for example, when you have two surfaces that are right up next to each other in a flat wall like this here, we may not want to have that lighting discontinuity. Now, in order to sample the light enough times to make sure there's no discontinuity there, we'd have to do way too much work, and that's just not going to happen. So what we can do, though, is the reason that I architected the system the way that I did, now when I sort of said, oh, let's make it so we pass down those lighting indices, is when we do our world gen, it would be free for us, as long as we put the logic in the generator properly, to say that when we have a situation like this, share the lighting samples across the seam, right? Because what we can do is place lighting samples across the surface, and the lighting samples can be placed right on the seam, and both of these two faces can share them. That way, when we interpolate the lighting across, the seam should relatively disappear, right? Now, we may have to do some special work with our interpolators to make that really be seamless, because interpolating scattered point sources is kind of difficult. So, you know, it's easier said than done, but in terms of computing the information we need, I think we can do it. And that'll give us smoother washes there, right? So we have some work to do with the interpolation, and we definitely will have some work to do at world gen time. But now I think we're in pretty good shape as far as that's concerned, because I'm getting the kind of results that I want from the lighting system, and everything is fine, right? Now, it's worth noting that we still have a lot of problems to deal with. If I was to make the world slightly bigger, it's going to get too slow. So like I said, we kind of need to start taking more steps now to sort of make this into a solution that's scalable to things that are as large as we might be using. So if I kind of go into world mode now, what I'd like to do is take a look at what happens when we start to build out things to as big as we're going to, kind of let them fail and be too slow, and then we'll sort of try to start to push forwards from there. Okay, so let's take a look at what's going to happen there. when I do add standard room, what we can see here is we're only adding like one of them. Let's say we added two of them. You can see how much more our solution slows down, right? Because it doesn't have any scalability built into it. Now, I'm pretty sure that it's not the actual rendering that's taking the time. However, we probably want to verify that that's the case. So what I'm going to do is I'm going to go, well, actually, I don't even have to do that. Let me just go ahead and turn it off temporarily. So here I have turned off updating of the lighting solution. And what you can see from the results is that it's really just that lighting update, which is what we would expect. But we want to make sure that's true. And so what you can see is it's just the lighting update that takes the time. So once you have the lighting solution submitted, the per pixel interpolators are not causing a problem, right? I'm spinning this around here just fine. And you know, the frame rate is not a problem at the moment. But once I tell it to start recalculating the lighting solution, you can see we go up to a really expensive amount of time, and then when I turn it back off, we're right back down to a reasonable frame rate. Now we're not great because we still have the weird we do too much work still in our renderer because we do the multipass nonsense and stuff like that. So you know, there's stuff that we still want to do to optimize our renderer, probably quite a bit of stuff we want to do. But you know, this is still totally usable at this stage of development, no question. Right? And so what we see here is just that it's that lighting update that's taking the time. So what we're going to have to do in order to start scaling out to more rooms, because obviously, like, you know, we get up to something like 4 and it will be completely unusable in terms of real-time lighting, right? So you can kind of see here, here is a thing that's got rooms stacked on top of each other. I thought I said 4. Oh, right. We only can see 3 of them. We fade out when we get to the bottom. Is that correct? Am I right about that? We need to add a way to debug move down. I don't currently have a way to do that. And why is the world small? Let's fix that. All right. So now I should also be able to kind of go down the stairs, I think. Although, did we make the rooms... I think we made the rooms too high as well, so you can't actually get down them anymore because the steps were like too far apart or something of this nature, right? But here we can see the lighting operating on sort of a more three-dimensional level. And you, again, can see that it really is starting to work the way that I wanted it to work, where, you know, if we do an update on it, it does produce pretty much exactly what I would have wanted. Now, of course, the problem is the update only kind of blends in over time, so you have to do several updates to get a real solution. You can kind of see how slow it is updating the lighting, right? But if we were to speed that up, which I think we can really easily do, well, easily, I think there's direct ways of us getting to that point, I think we'll be in good shape. And so, you know, again, looking at this, I think we're almost there. This is, again, sort of more representative of what you'll be looking at on the screen when you'd actually be playing, modulo the fact that the, you know, the artwork is not really what we would be normally doing. But if you take a look at what you're seeing on the screen right now, that's sort of more representative to the level of complexity on the screen that you would be looking at. And what you can see here again is that, you know, we're still at 30 frames a second even without the without any optimizations really in the renderer. So we're pretty good. Like, I really just don't think we have too much to worry about. So this scheme, I think, will be fine. And it, again, captures a lot of the stuff that I wanted to capture. You know, you can get lighting that kind of plays off various places here, and you get, you know, all sorts of nice sort of effects happening there. If I go ahead and sort of stop it at the beginning where you can kind of see that people are in this, the places where their light sources actually are. Let me go ahead and turn the lighting off, or try to. Why am I not able to turn the lighting off? There we go. Well, that was really weird. What is going on? I got some weird hotkey stuff set up here. Oh, I'm pushing F5 instead of F4. So all I was doing was reducing the number of bounces. Ah, that's awesome. All right. So anyway, back to what I was saying. So you can kind of see that if you just take a look at the initial solution, it's doing roughly what I want. You're getting bounce light off of this from here, and you're doing all this stuff that exactly what I want to have happen. You look down here, you can kind of see illumination happening in kind of a cave-like environment where there's no, up here we've got the main light, debug light going there. Down here you can see we've got kind of the sort of localized effect happening here. So I think that is all good. Like, I think we're in good shape here. Yeah, and off we go. If I was to generate a lot more of these and allow them to generate any way they wanted to, so, in here where we do our random choice stuff, maybe re-enable the thing that lets us go any way that we want. Not sure. We haven't worked on that generator code in a while. But here's a lighting solution, for example, that is operating. Well, can I? Doesn't seem like it actually picked any. We gotta move on to world generation sometime soon, just so we have this routine is so broken. Okay, so here's this this guy right here is the problem. Yeah, so you can see here what I kind of was expecting to happen before, but that didn't actually happen. You can see that we've got too many points, like too many lighting points. So what I'm going to do is I'm just going to up, that lighting count. And again, my goal here is just to stress out the system so that we have a good example of, what it's going to look like. So I'll just go ahead and 2x how much we've got here. Again, these are 1D textures, so it's really just not a problem in terms of the storage or transmission of these per frame. The problem is just in the lighting computation, right? So if we take a look at what the lighting computed here, again, it does pretty much exactly what we want. Like, all the lighting is localized to where those lights were actually. Yeah, and this game takes place at night, and so I think this is kind of roughly what we want. So yeah, let me see how much time we have here. So we've got about a half hour left, I think, if I'm not mistaken. So looking at this, we can now sort of build a list of the things that we're gonna have to do to make the final lighting stuff. And again, like I said, I'm really pleased with the speed of everything here. It's just, this is running on a really good graphics card. So that fact that as you get in here, I guess just to say a couple things that aren't obvious potentially, that I'm just knowing in my head that I'm not saying out loud. So I want you to take a look at the frame rate up here. And what you can see is we're actually getting 60 frames a second right now. But if I zoom in, we are not getting 60 frames a second, right? And so you may wonder what is going on there, right? Because nothing has changed about the world when I zoom. Like, nothing's changing. The camera does not do anything to the world when it's in debug mode, right? When the camera moves in this mode, things can come in and out of the active simulation set, and all sorts of things could happen. So obviously, moving the camera in this mode, we would expect to see frame rate fluctuations potentially if we've got something that's not working particularly well or that's unoptimized or whatever. But looking at the game here, this camera is not affecting anything. The game is running exactly the same way. So why is it slowing down when I zoom in? And the answer is, although I guess I can't prove this immediately because we didn't look into it, but I'm assuming the answer is, this happens when the fill rate, right, the per pixel cost of the GPU is something that is slowing down the frame rate. As I zoom in, more pixels on the screen are filled, right? When I'm out here, the whole world occupies very few pixels, right? And the less number of pixels it fills, right, the less I am seeing the frame rate hit, right? If that makes sense. As I zoom in, I get slower and slower. So that's what I was seeing before. Although I'll be honest, that's not happening now. I'm not entirely sure why. It was happening before. Let's take a little look here. Maybe I'm wrong. So I'm assuming that peak message being the thing that is taking all the time would have to be because that's where we're actually getting the OpenGL render time, where we're actually seeing that. I could be wrong about that. Let me run this again and see. So here we are. I'm going to switch to debug camera. You can see we're running at 20 frames a second here, 16 frames a second here. So that's interesting. Peak message actually starts taking more time later. We must have a bug in our Windows message loop. I mean, look at it eating up this time. And look at where it is now. Okay. Really don't want to know what I'm going to find when I dig in here. I'm hoping that it's just, hey, that's where the time's getting attributed to while stuff is happening on the other threads because of rendering or something. If this turns out to be another one of those Windows 10 dingus maneuvers, I am just going to be a sad, sad panda. So, if you remember, we had this problem where we were getting Windows 10 sending us a bunch of junk messages, right? And we were doing stuff where we would say, okay, if the thing we needed to do was, if we needed to skip a message, right, then we would. So I would like to know which messages we're getting here where, because you can see this is the block, the peak message block here. This is where we're hanging up behind sucking down all this extra time. And I have no idea why. Now, let me just double check something real quick. As you can see, we're holding pretty stable in terms of memory usage. Let's just double check that assumption. Where's the resource monitor thingy-me? Here it is. They always move these things around. I never know where everything goes. So you can see here that we're pretty stable. We're not doing anything weird, right? We're hardly taking any memory, really. In terms of what we're touching. We do still do that weird thing where we reserve a bunch of memory we don't use, which we should probably stop doing because we don't really need to do it anymore. But you can see the stuff that's in the working set is mostly not changing. So, yeah. You know, it could just be me, but it sort of seems like the more I do stuff in the window, the more peak message starts to show up. I'm not sure I managed to get it all the way to the top before. But I would really like to know what was going on there. See how it's crawling up again? See that? You seeing this? So with it up at the top there, I'm going to go ahead and just set a breakpoint in there and see if I can figure out what is happening. Now, unfortunately, we're not in debug mode, so I may need to change back to debug mode at some point and disable the lighting just so I can be able to like inspect more stuff. In the loop here. But we can see I mean, that doesn't really look like it's hitting very often. And you'll notice now it got sent back down to the bottom. I wonder if there's something getting done with our queue. So there we go. I've gotten it back to the top, right? Holding steady right there at 25% of the time in the peak message loop. Let's just Alt-Tab, Alt-Tab, and it's gone. So Alt-Tabbing away must make Windows stop doing whatever spam it was spamming us with, right? And it wasn't necessarily spamming us. It could just be that it was... Well, in fact, we know it's not spamming us, because take a look at what this must mean. So let's just go ahead and look at what we're talking about here. So here's where I enter the timed block. I go through this loop, skip index, only this many times, right? Paint, mouse move, OX738, and FFFFFF, right? Now, we then exit the timed block, right? So it's only timing this thing in here, not the outer code. Like, we're not counting any of this operations at all. And it's going to tell us the count. So if we look in here, right? If we look in here, when peak message shows up on here, which it doesn't at the moment, but we can make it show up, I suppose, or try to make it show up. There it is. It has a 1 next to it, right? So it means it only went through that loop one time. You know what I'm saying? So it just went through here once, got the message, and left. Which means it didn't get a message at all. Right? Yeah, I mean, it just didn't process any messages. So then if I come through here, on these frames, it should be getting a mouse message, right? So if I was to do, let's say, right when it hits about here, I'll do a mouse message, right? And then I pause. I should be able to go back here and see peak message being done with a 2. And there you can. So that's me clicking the mouse, right? I got the message, right? This thing is so cool. So we know that we're not even getting any messages when this says 1. That's just the exit condition. So that's just how long it took Windows to tell us that we don't have any messages the 4 times or whatever we call peak message, right? So let's go ahead and just spam this thing with tons and tons of mouse movement like we were doing before. And now what we see is that peak message is taking 30 some odd % of the time, right, to do nothing. So it's not returning us a message. It's saying we didn't get one. And yet it's taking 34%, 36%, whatever of the time to not do something. So it must be doing something during those calls that, you know, we can't see, right? Now, one thing we could do here is be more specific about the profiling, right? So what we could do here is say, all right, let's put the time block in the actual loop. So we should see it be called, 4 times or whatever to do the 4 ranges. So 0 to WM Paint to mouse move 738, 738 to FFF, right? So now our default value of peak message while we're running should be 4 all the time, right? And hey, it is. That's what we would expect. So then I come in here and I wangle around a bunch, right? Wangling. Like so. And now what we can see is, yeah, we've worked peak message all the way to 4, right? And it's taking 26% of the time. So we've definitely verified that we're just calling it 4 times for each one of those ranges, and calling it those 4 times has caused us to have a 30% ding on our frame rate, which is huge, right? Absolutely huge. It's nuts. It's taking as much time as the graphics is taking, right? Like, do all this unoptimized GPU work we're doing, it's all taking the same amount of time as the peak message, basically, if we just wiggle the mouse enough. Look at that. So something is seriously messed up here, and I don't know what. Only the sort of, rocket science team over at Microsoft that can't figure out how to deliver a message in less than, what was that, multiple milliseconds, know what's going on with that special sauce. I'm imagining that part of the problem might be because we are trying to avoid this bad situation from happening, where we're getting spammed with these messages. Maybe that is causing some kind of an odd problem to occur. I'm not sure. What we can do is we can test some theories here, right? So if we put the time block back where we had it before, right? So we're timing the peak message on the interior. What I can do is say, well, all right, if I go ahead and do a bracket around this, and then just, say, give me all the messages that you might be inclined to give me, and maybe call this in a way that's more consistent with what it normally would do, right? So I believe it's just 0 and 0 here. We'll just do that. And this will allow me to test the sort of more straightforward path to see if anything weird is happening about the call pattern that we were using to try and avoid spurious messages, which we were getting. So here's the profile. There's peak message. And what you can see now is just moving the mouse will cause a 2. The reason for that is we're now getting mouse move messages. So mouse move messages, we are not skipping the mouse move message, which we didn't want. And so let's see if the same thing happens again. So it looks to me like you can't skip those mouse move messages, right? It looks to me like something about calling it that way is making Windows get very confused about what it should do. We had changed it to this way based on a suggestion from a viewer who was saying maybe we could avoid getting spurious mouse messages. However, I'm going to go ahead and say that that's maybe not such a good idea after all, based on what I just saw. Now let's take a look and see how accurate that actually is. I'm going to go ahead in here and say, well, all right, let's re-enable this path. Maybe let's take out the WM mouse move or the WM paint and see if it's one specific one of these that is causing the problem, right? So I've put us back to doing the range-based query, and I'm going to take a look now to see if I come in here and take a look at the profile. I'm going to make sure that I can generate the same bad case just by rapid mouse movements, and already it's, doing sort of worse than it was before, with peak message moving up to 25% of the time. Let me zoom out and get it to take up even more percent of the time, right? A ridiculous number of cycles here being taken by peak message. So let's go ahead. I mean, you can look at that. It's fucking, that's, oh, another swear. Damn it. All right. One more episode with swears in it. Gotta like bleep. We need a little sensor. Someone needs to just be able to push like that little button that's like beep. I think we're up to like 6 now or something like that. 6 episodes that have curses in it, something like that. It's not great. I mean, compared to the amount that I swear normally, it's fantastic. But what are you gonna do? Anyway, so look at that. It's ridiculous, right? I mean, I don't know how that's even a remotely justifiable amount of time to be spent dequeuing a message, and more specifically, not dequeuing a message. That's how long it's taking to tell us it doesn't have anything, right? Microsoft Windows is the only thing that can take, 19 million cycles to say, I don't have anything for you. So we need to address that. Again, now that I know that I can produce that again reliably, let's comment out the paint. Looks like peak message is slowly moving up, exactly as we would expect. And the fact that it seems to be triggered by moving the mouse does suggest that, mouse move is an obvious sort of potential culprit. Let's go ahead and take it out the mouse move. So now we will be sampling mouse move messages. In the actual loop here. Looks to me like that is indeed the culprit. So as I kind of suspected, you can't leave those WM mouse moves in the queue. So paint can be skipped. OX738 can be skipped. But mouse move can't be skipped. So that, not exactly what I wanted to do at the end of today's episode, but definitely good that we found that. And I guess what I would say, just to reinforce something that I said originally back when we built the profiler, when I originally built the profiler, I was actually asked the question specifically why I was building the profiler and the debug system when I didn't really have a need for it at the time. And the answer is, specifically this. That is an example of a really, really problematic scenario. If we had started to do some profiling on particular pieces of code or just looked at a frame rate counter and saw that we were getting these slow frame rates there, we would have jumped to the conclusion that it was us and we would have been weirded out by this, or maybe never even known it at all. But because I happen to have that profiler running all the time, it makes it easy for me to see that it's not our code that's causing the problem, it's Windows that's causing the problem, and we could quickly identify the fact that where that problem was and how to mitigate it. So now our frame rate is not affected by this. We can go back to using those frame rate measurements more reliably. Now, why this is happening, I have no idea. Maybe someone who works for Microsoft can go help you go into the code for peak message and find out what kind of special, let's just say what kind of remarkable procedures are occurring in there that are causing it to take 5 million cycles per call to tell us that nothing happened. And if we ask for our mouse move messages, all of a sudden it's fine. I'm guessing that something happens like there's a mouse move queue, and if you don't drain the mouse move queue, it fills up to a point where it causes a spillover scenario that's somehow slow. I don't really know. I'm really making stuff up at this point, but it kind of looks like something like that is happening. Now I'm concerned. I'm worried about what might be happening here. And so what I would also like to do is I'd like to try and check to see whether a similar scenario can happen with Paint. So I'm going to go ahead and try to trigger lots and lots of Paint messages and see if the same thing happens. So it doesn't look to me like Paint has the same kind of drawback there. I may just not be able to generate enough Paint messages. I'm not sure. It's hard to know how many Paint messages are actually being generated by various mouse movements. You can see that Paint messages are would be generated here, I'm pretty sure, and I think they're generated all through this whole procedure. I believe anyway. But I couldn't tell you for sure. Other thing is Paint messages may be getting dispatched directly to the window on drag. So it may be that they are getting handled anyway. I'm not sure. Let me go ahead and see to what extent that's true. Yeah. So you can see that those are getting dispatched directly in this case. So if I go ahead and move up here like this, yeah, you can see they get dispatched directly. So the fact that we're not asking for them is not really changing the situation pretty much at all. And in fact, I'm not sure why. Yeah, again, I think this may have just been a bad suggestion from the person who suggested that this was the case. Because I think they were just wrong about what happens with like the Paint generation. Because as you saw, they get dispatched directly to the window anyway. And I'm pretty sure that they don't actually get generated in any other circumstance, right? So if you look at what's happening here, we're not getting we're not getting any messages till the circumstances where we were getting the messages. So I think that might just be bad, right? That might have just been not the right thing to do. I guess what I would say is I still don't know about this, though. This 738 does seem like a bad situation. So we may keep skipping that one. I'm going to go ahead and see what happens if I turn that off. And I don't remember the exact circumstances under which we were getting lots of these messages. Maybe they fixed that. So it's hard to say. I really can't test that one. All right. Let's go ahead to the Q&A. Someone says, did you notice that the annotation search doesn't seem to be working anymore? No, I did not know that. I generally don't test it or anything because I don't maintain it, but I agree with you. That does not seem to be working at all. If someone could remind me, well, you know what? No, you don't have to because I can just do it right here. I will send a mail. Let's see here. All right. I sent a mail about that. Yeah, I don't know anything about this system. Obviously, this is just the hard work of both Miblo and the folks at Handmade Network in terms of the hosting of it. I would suspect, I know that the way that this works is Miblo wrote a system for doing annotations, and it gets like munged into the Handmade Network something. And probably in that munging, something has gotten lost in translation, would be my guess. So such that the search stops working. I don't really know, but that'd be my guess. So hopefully it's something simple that's not going to cause them a huge headache. I don't know. ChaosCom, why do you call peak message once for each element in the skip list instead of retrieving the message once, if any, and comparing it against the message you want to skip? The reason for that is because what we were trying to avoid was Windows generating messages on demand. So the way that Windows works is that some messages get generated apparently when you ask for them, and if you don't ask for them, they don't get generated, right? And so we were trying to avoid ever asking for the things in the skip list. We weren't trying to skip them because we don't actually need to skip them. We're okay if we get a mouse move message back. It's fine. We'll just ignore it. So that was what we were trying to do there. But I think that may have just been incorrect advice on the part of the people who suggested it. Final space. You got that messages while debugging with the NVIDIA GPU dev thingy. Correct. Thank you for refreshing my memory. Yes. That is exactly what was happening. I'm going to add that in here. So let's see if that is actually what's going on here. Where's my HUD? For some reason, my fonts are not here. That's weird, I would say. That makes it a little harder to test. But I guess it's not impossible still. I'll just do... So I'll just go ahead and break on the situation where wait a minute. Is there no way to actually... Oh, right. It's not going to like that. So, okay. What I could do is say... I know, a cheap maneuver, but the optimizer won't see it coming, maybe? Maybe it will. Try one more time. I'm not having any luck. All right, fine. So I am getting that message even without Nsight running. Which is kind of interesting. I wish we knew who sent it to us. Yeah, so this is correctly preventing that from occurring, right? So this is not really true. But it does look like it's not creating enough of a problem, I guess. Okay. I heard you've talked about it already, but do you have any comments you would like to make about Meltdown Spectre on the record? I missed the pre-stream. Yeah, I can summarize what I said in the pre-stream really easily. Basically, my opinion is that currently, if a machine is running an executable of any kind, really, JavaScript, x64 native, whatever, it's an insecure machine. The only way you can have security is to actually know that all of those things were written by you or people you trust, and that that they weren't trying to compromise your machine. So the current state of affairs is that I don't know that Meltdown or Spectre really change that at all, because they're just yet another way to do some slight, compromising of something. But you already could have done that compromising in thousands of other ways if you are running any kind of code on a machine. So I just see them as bugs that need to get fixed in the hardware, because we do want the hardware to eventually be stable and secure. I don't see them as changing the software landscape at all, because the software is currently insecure and simply remains so after Meltdown and Spectre. If I thought there was any way to secure a machine that was running foreign executables on it, then these would be concerning, because they would be the first ways that people could have done something to that machine. But that is just simply so far from the case that I think it's kind of laughable to think that they changed the landscape at all. I mean, I just assume that, I assume the Handmade Hero machine is easily compromisable, because, it's got Steam installed on it. And people can pay $100 and post an executable on Steam, and I download it and I run it, and it owns my machine, right? I'm just assuming that can easily happen, right? I assume that if I run a web browser on a machine, it can easily be compromised, right? I just assume that. So those assumptions don't change in the face of Meltdown and Spectre, so that's why I'm not particularly concerned about them. If we got to a world where that wasn't true, then I think they would be more concerning. Dragoon X6, what in your opinion is the biggest lie myth most programmers follow or believe in? I think I would say that generally it's just that there's such a thing as clean or elegant code that isn't about measuring something in the code, right? So that seems to be kind of the root of most bad things in programming. It's people who think there is something about code that makes it good that is not something they have measured or tried to measure. And that drives a lot of the stupidity around programming practices that are counterproductive. What makes code good is the total time of maintenance on that code, from creation to shipment to updating, right? And if you're not measuring that and tracking it back to actual things, then you're just kind of making stuff up, right? To make yourself feel good. And so a lot of what I see that's talked about in terms of when people say things like best practices or what they look for in code reviews are things that they actually have never really done any due diligence to determine are actually effective. And also, furthermore, what is or is not an effective programming practice is not universal. It depends on the programmers who are deploying it. Programmers make different kinds of mistakes. I will make different mistakes than you will. Some programmers make more mistakes than others. Some teams make more mistakes than others. Things that you're doing in code to help make mistakes had better be targeted at the people who are actually maintaining that code. Otherwise, they are a waste of time. Guarding against mistakes your team won't make is a waste of time, right? And so talking about a programming practice as if it is universally good is often also misguided, because usually things are only locally good. There are probably some programming practices that extend to all programmers. However, a lot of programming practices only extend to some programmers, a subset of programmers, and not knowing which programmer you are or your team is also going to mean you can't really make any kinds of statements about what you should or should not be looking for. Hey, Casey, do you know about SFML? If so, what is your opinion about it? No, I do not. Masfielda, what do you mean when you mentioned browser security is a concern these days? Should the OS be secure instead of the browser or something like that? So in my opinion, I don't think security would be particularly difficult to achieve actually in practice. Or rather, I don't think a fairly high level of security that's much higher than what we currently can achieve would be difficult in practice. If you took all of what we're doing right now and completely threw it out and just said, this is all wrong, and went back to the drawing board and said, the goal of us creating a computer is to have it run one thing at a time, and that thing can only, communicate effectively by like packets sent back and forth, then I think we could achieve a much more sane level of security, right? The concept that when I run a game on my machine, that it can even see or think about the other things on the machine at all is nuts. And yet that's just the standard behavior, right? There isn't a single operating system that I know of right now that even considers it important to make those kinds of hard delineations, right? But they do. So yeah, of course, like the concept that I have a web browser and the web browser opens multiple tabs and those tabs are all running in the same, conceptual space to a large extent is nuts. And yeah, browser manufacturers are doing a better job now of at least splitting them to separate processes. But the point is, why are those things even considered in the same space? Why do they even have access to the same things? Why are they even seeing the same hard drive, right? It doesn't make sense to me. So I think the way you would achieve real security is the same way I achieve it, some measure of security in practice. I have a machine for development and a machine for browsing the web, and never the two shall meet. I transfer data between them in the most secure ways I can possibly think of, but that's just how machines should have been architected, right? Like, you should be able to run a machine such that it's essentially running only one thing. And, let's say I put 2 hard drives in my machine. One is for development. I boot on that hard drive. I should be able to switch that machine over to then running a separate hard drive for when I'm doing my web browsing, and that should be fairly instantaneous, right? Like, that's how things should be designed. Physical, actual, separate security. And that way, the only thing you're trying to secure is just the very small transfer part between those gaskets. Whereas right now, it's everything. The same kernels mapped into the address space of all the processes. It's running them all at the same time. I don't even know what's running on this machine. What is all this crap? None of this should be happening, right? The fact that that Microsoft even says the word security when this is what a tab of currently active things looks like on their operating system is ludicrous. This is not secure at all. There are so many backdoors. I don't even need to know anything about the code in here. I guarantee you that just the fact that the number of things on this list, this is a default install of Windows 10 that's have almost nothing installed. It's like Visual Studio, right? That the list is this long alone tells me that there are backdoors upon backdoors upon backdoors in this operating system just waiting to be found. And they will never find them all. Forget it, right? So all we're doing right now is having a big old fun rat race to see whether the people at Windows and other security research firms who are white hat can find all the hundreds of thousands of bugs that are in this list alone, right? Let alone all the other stuff that's running when I come. This is just the services panel, right? How about the process panel? What's all this stuff? Right? It's nuts. So just this, the size of this list should be one thing, right? And, maybe in this case, 2 or 3, because I'm running 3 things that are actually talking to each other. So this list should have 3 things on it, right? And that's it. And until then, talking about security is a joke. And thinking that cache timing attacks are your primary problem and that, oh my god, like, we've got these cache timing attacks. Come on, man. Like, yeah, cache timing attacks are a problem. Do I want Intel to start designing hardware that doesn't have them? Yes, obviously. Are they relevant to how many billions of ways Microsoft has already dropped in here for us, for our people to slide right in and compromise your machine? No. Absolutely not. They're going to fix these cache timing attacks, and then there's still going to be 800,000 different ways to pwn your machine by sending the right GIF to some stupid thing in here that's in the photo viewing service or something, right? So it's pointless. Dragoon, do you think code reviews and or writing tests helps with that? And that meaning be the lie myth that most programmers are forced to, or aren't thinking about what's actually effective. I guess I would say it's just a meta statement, right? I don't think code reviews or writing tests help or don't help in an absolute sense. Almost everything you might do in code that is not directly producing code you use, so I'm literally writing a routine here and optimizing this routine or something. Everything you do, putting in const, putting code reviews in place, writing test code, stepping through things in the debugger that aren't for finding bugs, just to watch them, right? Talking with people on a whiteboard, blah, 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 right? All of those things are not good or bad in the absolute sense. They have effects on your productivity, sometimes positive, sometimes negative. And whether or not they are generally good practices depends on the circumstance and the team. Some teams would be better off never doing a single code review. Other teams might be better off doing code reviews fairly frequently. Other times, and I suspect this is often the case, code reviews might be a good idea when you're bringing new people on, but become not such a good idea later when everyone kind of knows what's going on, right? And again, that all depends on, it's a time trade-off that you're making. If you spend 1,000 hours doing code reviews to save 100 hours of debugging, you're making a huge mistake. If you spend 100 hours of code reviews to spend 1,000 hours of debugging, you're not, right? And so you have to tailor things to what your gains are, right? Similarly, there's risk-reward trade-off. Some software goes out the door. If there's a bug in it, it doesn't matter. It's not that big a deal. That bug is relatively harmless. It can be patched. It's just not that critical. Other software goes out the door. If there's a bug in it, it could cause a catastrophic failure. The classic example, launching a rocket into space. If there's a bug in some piece of software there, it could mean the entire, $100 million rocket gets lost. Well, do I want to spend a lot more time reviewing the code and testing it in that scenario? Absolutely. And so again, you always have to go back to think about what I am trying to do. We are trying to be more productive. We're trying to produce the same quality software with the same number of features in the least amount of time. Are these things that I'm doing making that happen? Are they really making that happen? Or am I just doing them because I watched some stupid video on YouTube where some engineer who didn't know what they were talking about told me it was a good idea, right? Or to be slightly more generous, some engineer who did know what they were talking about talked about something that they did on their team, but that just doesn't apply to your team or you, right? And so that's really the thing that's really crucial to get into your head, is like, it is all relative. There is no such thing as a universally good programming practice, except possibly in the very smallest cases, right? It's like talking about, all of all of the things that you might do in a day, like which ones of those are good habits and bad habits, right? Well, who are you? Which person are you? What's your goals in life? All of these, how old are you? Like all of these things change what is the right advice to give someone, right? And the same is true for programming. You just can't boil it down to this is what everyone should do. And so you have to be willing to be flexible, and you have to be willing to go, how do I analyze my choices all the time to see whether what we're doing really makes sense for us or whether we're just wasting our time, right? And it's the same answer for everything. When people ask me about test-driven development or all their other buzzwords, right? Agile programming, blah, 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 whatever it is. The answer is always the same. Some of these practices are good some of the time, right? And you have to develop the skills to critically assess whether you are wasting your time or not. And it usually is pretty obvious if you actually take a bird's eye view of it. You know what you're spending your time doing, and you know whether it's finding bugs or producing better code if you actually measure something you care about, right? How long it took you to write the code, how many bugs got found in that code, how easy it was for someone else to maintain the code. All of those things are actually things you can sort of get a handle on, not that hard if you look. But if what you always assume is someone told me X or clean code means X or whatever, and so I think that this was better because we ended up with this thing that's an abstract concept, the answer is no, that's wrong, right? That did not tell you anything because you didn't actually measure or observe anything that actually matters to the code that you're shipping, right? And that's the crucial part that you have to make sure you develop all the time, right? You have to always be thinking about this. Am I doing stuff right now that is just wasting my time? And the converse is, if I'm identifying things that are taking too much time, are there programming practices out there that can fix that waste of time, right? And that's a good example, right? The simplest possible thing is with const, right? There's two examples. So let's say you find yourself having a lot of bugs in your code where you're modifying things that were not supposed to be modified. Add more const. That's what const is for. Add more const, right? On the other hand, if you find that you're never having const errors, right, in the compiler, but you've been adding const all the time, that's a good thing to say, hey, maybe I shouldn't be using const so much because it's obviously not catching any bugs for me, right? So you can always figure out ways to look for, are these things that I've been told are good or that I think might be good, are they actually saving me anything? And by the converse, you can usually say, am I finding myself having problems that there is a coding practice out there or something that's been advocated that might address? In that case, let me experiment with it and see if it does address it, right? And so you can usually figure out a way to check both sides of something, right? And you should. Whichever one you're doing, if you are doing a practice, there usually is a way to start checking, is this practice actually doing something for me? And if you're not doing a practice, there usually is also a thing to say, is there some canary in the mine shaft that is telling me, hey, I'm having this problem, maybe I should start doing this code practice to help fix it in these circumstances, right? Let me just quick do any more. I watched the first 50 or so episodes of Handmade. Here, a quick question about the current state of things. Is GPU OpenGL shaders part of the product now? Yes, there is a GPU accelerated render in the product. That's what we've been playing with recently. When do you plan on adding in the new art? Just as soon as I'm comfortable with where everything is in terms of rendering. Opinion of the .NET Framework platform. It's garbage. One argument I get from people that use advanced C++ features is that the resulting code is more secure and robust. Do you agree with that? Nope. And the reason is because the advanced C++ features, as far as I can tell, are rarely about doing any of such thing, right? C++ is not a language that's designed for robustness. And I've never seen them add a high-level construct that was effective at achieving it. So I mean, I could talk about a specific advanced feature, but, you know, I mean, the obvious things that improve code robustness are things like metaprogramming, and they don't really support them. I mean, they don't even support introspection yet, right? That's like a brand new thing they're adding in the latest stuff. And, you know, simple things that create secure and robust code are things that allow wide application of solid principles and the modification of those principles. And C++ doesn't have, it really doesn't have any features for that, to be honest. It's almost feature void in terms of that. So. All right, I'm going to go ahead and close this down. All right, thank you everyone for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. If you want to follow along the series at home, you can always pre-order the game on handmadehero.org. We also have replaced the Patreon page with a contribution page where you can contribute to things like the episode guide, which funds development on things like that. So if you're interested in contributing to the series, that's the place to go for that. And of course, the episode guide is always there. We also have a schedule bot if you would like to go and find out when the series is going to be live. But I can tell you right now, it's going to be live again tomorrow in 21 hours, 29 seconds, and 21 hours, 29 minutes, and 5, 4, 3, 2, 1, 0 seconds. So I hope to see you back here for that. We are going to take some next steps in our lighting to try and get us to a place where we're sort of happy with how that's going. Again, the goal there now is to just sort of scale out this solution, clean everything up, and wrap it up in a nice bow so that we can have lighting wherever we want it in the game and not worry about it slowing down our performance. So we have some work to do there, but thankfully we've kind of cracked, I think, the lighting problem in terms of what's appropriate for our game in terms of the architecture. So I'm pretty happy with that, and I think we'll have some success there as we move forwards. That's about it for today. Hope to see you back here tomorrow. Till then, have fun programming, everyone, and I'll see you on the internet. Take it easy, everybody.